Okay, so today we're going to start 9.2 and then tomorrow we'll just be getting practice and it's going to be with the binomial theorem. And so really what we're dealing with is when I have a binomial raised to a power that's not squared, is there a fast, easy way for me to get what the polynomial is? So let's go ahead and go get the powers of a binomial. So I don't know if you remember, notice it is in a triangle form, and we'll talk about why in a second. But so anything to the zero is the first power. So a plus b to the first, I know that it shows powers of a and b for all of them, and that's on purpose so you can see how they change. But so with this one, when I raise a plus b would be to the zero in the first term, and a is to the zero in the second term. So a and b are present in every term of our polynomial. It just depends on what their degree is. So the first one will start off at the highest degree, and then you're going to count down. So it would go 2, 1, and then 0, since this one is squared. And then b would start with 0 and count up. So it would go 0, 1, 2. Okay, so that pattern continues with all of these. The only difference is these coefficients and where they come from. So I mentioned the triangle is important. And so for the triangle, how do we get those coefficients? That's where they come from, as the triangle, which is Pascal's triangle. So you can make Pascal's triangle in whatever size you need. So you would start with the first power up top, not first power, you'd start with one up top, and then one goes from side to side. Okay, so one will be on this whole diagonal, both top and bottom. So we end up getting the other values by doing the sum of the two numbers diagonal above it. So 1 plus 1 is 2, and then 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And that's how I get the fifth row. So if I wanted to make the sixth row, that would be 1 and 1 at the ends, and then 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 1 and 5 is not 5, it is 6. So you continue and do as many rows of Pascal's triangle as you need. I would make a rough draft of Pascal's triangle and use it in your homework because it'll make some of these problems go a little bit faster. Or the other option is for, depending on what term you're using, you can use, so if my power is n, oh, hold on. So if my power is n and your term number starting with 0, so from the last one, when I had 5, so if I had 5 choose 2, that's going to tell me essentially what the third term is because 0 counts as the first option. Okay, and so that'll give me information to fill in and make some of these go a little bit faster. And so, or you can use the binomial theorem. So instead of doing a plus b, I want to switch this one. Oh, sorry. I want to switch it up, and I want us to do, let's expand x plus 2 to the fourth. Okay, so right now I'm just going to draw blanks when I have places for coefficients. I'm just going to write down the exponents. Okay, so I'd have blank x to the fourth, 2 to the 0, plus blank x to the third, and then 2 will go up a power, plus blank x squared, 2 squared, plus blank, I'm not going to have enough space, I'm going to write in the next row, plus blank x times 2 cubed, plus blank x to the 0, 2 to the fourth. Okay, so if you look back at Pascal's triangle, you can go ahead and get all of the individual terms for coefficients. So those coefficients would be 1, 4, 6, 4, and 1. You get those off of Pascal's triangle, and that it's technically the fifth row because that first row is the 0 row. Okay, so with that, I still need to go simplify. 2 to the 0 is 1, so that first term is just going to be x to the 4th. Plus, well, 2 to the first is 2 times 4, I'd have 8x cubed plus 2 squared is 4, 4 times 6 is 24, x squared plus, well, 2 cubed is 8 times 4 is 32x. And last but not least, 2 to the 4th is 16. And so that's going to be this polynomial. And so you just have to look out for terms individually. So if you want to use your calculator to find out all the coefficients and not have to do Pascal's triangle, I'm going to show you how to do that. So in your calculator, what you can do differently, so if I wanted this one that I decided not to do the last time, when you enter for the CNR that we learned on Thursday, if you do curly brackets on your calculator and then do 0 up to 4, so whatever your n is, go up to that number, it's going to give you all of your coefficients at the same time and you don't have to do them individually. And then you'd put them in front of each term. You're still going to have to write out your powers individually though, okay? And so that'll make this a little bit faster for you. So, give me one moment and we're going to go do one more example. Okay. So before I give you the example, here is your binomial theorem, in which gives us all the individual pieces. So notice that instead of writing CNR out, we've shortened it to parentheses and having the 2 inside, no fraction, okay? So, and that's just representing the CNR, the combination formula that we learned on Thursday, okay? So let's go and look at expanding this one, okay? So if you want to use the binomial theorem, let's do it that way this time, or you could use Pascal's triangle. I really don't have a preference for you. So to start off with, I would have, because I have the 5th term, I would have 5 choose 0 as my coefficient. And then I'd have z cubed to the 5th times, oops, that looked like a 15, 5x squared to the 0. And I'm going to write all of these terms right underneath each other because otherwise I'm going to totally run out of space. So then it would be not equals plus 5 choose 1 z cubed to the 4th 5x squared to the 1st plus 5 choose 2 z cubed 5x squared plus 5 choose 3 z cubed squared 5x squared cubed plus 5 choose 4 z cubed to the 1st 5x squared to the 4th plus 5 choose 5 z cubed to the 0 times 5x squared to the 5th. So those are all of my individual terms for this polynomial. And so with that, I can go and simplify them now. So that goes to 1, and so I'm left with z to the 15th. And we're going to be adding all of these together. And so then I have, and 5 choose 0 is 1. I forgot that little piece. Okay, and then we'll be adding, well, 5 choose 1 is 5. I got that either from Pascal's triangle or by doing the 5 choose 1 in your calculator. So that's going to be 5z to the 12th times 5x squared. So you are not done with this term because I have to multiply that 5 times 5, which is going to be 25x squared z to the 12th, or z to the 12th x squared. The computer should take it no matter how you type it this time, but I'll keep it in the order from above. So z to the 12th x squared, which this will then equal 5 choose 2 is going to be 10, and then I have cubed, so that would give me z to the 9th. And then this is going to give me times 25x to the 4th, which gives me 250 z to the 9th x to the 4th. If I choose 3 is also going to be 10. And then this is going to give me z to the 6th. 5 cubed is 125. And then x to the 6th. So this will give me 1250 z to the 6th, x to the 6th. 5 choose 4 is 5, leaving me with z cubed. 5 times 4 is 625, and that'll be x to the 8th. So 625 times 5 is 3,125 z cubed x to the 8th. And then the last one, that's going to be 1 times 1, because that goes to 1, times 5 to the 5th is that 3125 again, and then x to the 10th. So the final answer is adding up all of these final terms together, and I'll show it to you all together in a moment. The key with these is when there's a number inside your A or your B, make sure to raise it to that power so that you can finish up the problem. So, sorry, that's Bear. He just woke up. Bear! So, here's that final solution. I forgot to include the negative. Hold on. Okay, I did not forget the negative. It just looked like I did. So this one should have been a positive 5x. So I don't know why it showed up negative. So over here, that's, oops. That is positive. That's positive. It's only negative if it's negative on the inside. And so all of these are positive down here. If it was negative on the inside, you would have to think about, okay, is the negative to an even power and odd power? How do I use that? And so that's it for new material and the end of 9.2 that we're going to cover. There is some more pieces in there that we are not covering together, and that's okay. Don't stress about those. And then so we'll have homework today, homework tomorrow, and then y'all are done with pre-cal. So I will talk to y'all later. Let me know if you have any questions or concerns or need any help. Bye, guys.